Welcome to the class, student. Last part of circle we are going to discuss today. Right, 4 parts are completed. In this part, especially we are going to discuss about common tangents and position of the circle and common tangents. Right, and if possible, we'll discuss some miscellaneous question at the end of the class. Okay, right. Let us start here. Now the question is, first one is common. See here, position of the circles. If two circles touch externally, this is C1, C2, R2, R1. Condition is C1, C2 is equal to R1 plus R2. Right. And the next one is they may touch internally also. So at that time, the condition is C1, C2 here. This is C1, C2 is equal to modulus of R1 minus R2, you can say. If two circles touch internally is like this, externally in this way. Now, suppose if the two circles are what? Going to cut each other. If they cut each other, then this is C2, this is C1. You know very well that this one is R1 and this one is R2. So what happened here? R1 minus R2 is less than C1, C2 less than R1 plus R2. This is the condition, please remember. And the next one, if the circles are what? Away from each other. Two circles are away from each other. Very clearly, C1, C2 it is. This is R1, this is R2. So C1, C2 is definitely greater than R1 plus R2. C1, C2 is definitely greater than R1 plus R2. The other one is if one circle is completely contain the other one. Right, like this. This is C1, C2, R1, R2 there. So C1, C2 is definitely less than R1 minus R2. If this condition holds good, one circle contain the other one, we can say. The next one is, see here, these are what? Concentric. C1, C2 is this. Concentric circle. Now, we'll talk about number of tangent, existence of number of tangent. Now, when you talk about number of tangents, directly here we have to discuss 2 points here. You see this, first of all, let me tell you clearly, common tangents. Common tangents. Common tangents are two types. One is, see this, one is direct common tangent. Direct common tangents. Direct common tangents. The other one is transverse. Transverse common tangents. Direct common tangent, another one is transverse common tangent, you can say. What is mean by direct common tangent? For example, this is a line. Let us say that the two circles lie same side of the line. Right, this is one, say that C1, this is what? R2, this is C1, R1, this is C2. If the two circles lie same side of the line, this tangent and touching the line on the same side, then you can say that what? Direct common tangents. Now come down to the transverse common tangent. Transverse common tangent means two circles are going to touch the line either side. Let us say that this one is C1, this one is C2. Okay, how many types of common tangents are there? Two types. One is direct, another one is transverse common tangent. Direct common tangent means the two circles are lie same side of the line. Lie same side of the line and they are going to touch the line. Like this, as shown in the diagram. Such circles, okay, if the circles are like this for a tangent, that tangent is called what? Direct common tangent. This is what? Direct common tangent. Here clearly in this diagram it is okay, it is very clear. The two circle lies either side of the line. Right, either side of the line, and this line is going to touch both the circles. Such tangent is called as what? Transverse common tangent. Right, transverse common tangent. Now after this one, you see here very clearly, if the circle's positions are like this, right, if the circle's positions are like this, okay, if the circle position of the like this, how many tangents are going to be exist? Okay, now you see here, this one, the circles are what touch externally. Now you see here, how many common tangents are going to be exist means, this is, both the circles are what, either side, so one transverse common tangent, the other one is, you see this one, this is one, another one is this, right, they may cut certain point. So I can say that one transverse common tangent, TCT I'll say now onwards, right, and two DCTs, overall how many? 3 common tangents. If the circle touch externally, you can say that how many? 3 common tangents are going to be exist. Whereas in this case only one direct common tangent, one DCT. How many common tangents are there means only one direct common tangent. Whereas in this case, you see this, you can see this one clearly, right? So 2 direct common tangents, 2 DCTs are going to be exist in this case. And in this case, not only direct common tangents, but also you can say that transverse, right? So 2 DCTs and 2 TCTs, transverse common tangent, direct common tangents, overall how many? 4 common tangents. Four common tangents you can say, right? Whereas in this case, no, 0. Whereas in this case also what? 0 number of common tangents are going to be exist here. See, position of the circle. So if anybody asks you that how many number of common tangents are going to be exist by giving 2 circles means, you are supposed to use this condition only. That if you are identify their original position, they touch externally means 3 directly, you can say they touch internally means directly 1, you can say they cut, you can say that 2, and they are away from each other, then you can say that 4 common tangents are going to be exist. This is the rule. With the help of this we can identify. Yeah, I have taken 2 examples here. The relative positions of the circle, I have taken 2 examples. Now you see here, what I am doing, center I am going to identify 2, 3. Radius, compulsory it is 4 plus 9 plus 12, you will get R1 is equal to 5. Now say here R2 is C2 is equal to minus 3 minus 9, and R2 is under root of 9 plus 81 minus 26 here. So clearly R2 is equal to 90 minus 26. So R2 is equal to 64, 8. Now what we have to do? We have to find C1, C2. C1, C2 is 2 plus 3 whole square, and here 3 plus 9 whole square. So this one is 25, this one is 144, this is 13. 169 means 13 you will get. C1, C2 is equal to 13, we got it. Now it is very clear that C1, C2 is equal to R1 plus R2. C1, C2 is equal to R1 plus R2 means the circles are going to touch externally. The circles are going to touch externally, we can say here. Whereas in this case, C1 is equal to minus 3 comma minus 3. R1 is equal to under root of 9 plus 9 minus 14. So R1 is equal to what? 2 over here. C2 in this case is 1 comma 2. R2 is in this case 1 plus 4 plus 4. That is what 3 we are getting. Now you see here, C1, C2 is like this now. Minus 3 minus 1 whole square plus minus 3 minus 2 whole square. That is under root of, you see that 16 plus 25. Root 41 we got it. Right. C1, C2 is equal to root 41 we have here. Now clearly C1, C2 is, okay, C1, C2 we got it as root 41. Please see this. Okay. Now you see here, C1, C2 is directly we can say that more than R1 plus R2. So one circle both the circle are away from each other, completely lights outside the other. We can say like this here. Yeah, one more area is there. I have taken here the number of possible common tangent to the circle. Very simple. We are supposed to find the position of the circle. With the help of that, directly we can find how many tangents are going to be exist. C1 is -3 -3. Okay, R1 is here 9 plus 9 minus 14. So R1 is equal to 2 you are getting here. C2 is 1 comma 2. R2 is under root 1 plus 4 plus 4. That is what R2 is equal to 3. Clearly C1, C2 we are going to find in this case -3 minus 1 whole square minus 3 minus 2 whole square. So you see this one 16 plus 25. Root 41 you got it. Root 41 definitely C1, C2 is greater than R1 plus R2. That means how they may be like this, right? They may be in this way. So if they are like this, how many common tangents are possible? 2 direct common tangents and 2 transverse common tangents are possible. 2 direct and 2 common transverse. So overall what? 4 tangents. Overall 4 tangent in that case. Whereas in this case you see C1 is 0 0. I have taken 3 cases. C1 R1 is equal to 2. C2 is equal to 3 comma 4. R2 is equal to under root of 9 plus 16 minus 16. You will get here 3 only. But C1, C2 is equal to how much? 9 plus 16. C1, C2 is equal to 5, which is equal to R1 plus R2. What happened here? First one, second one. Right? First and second, 2 circles are like this. So how many direct common tangents? 2 direct common tangents. Right? And 1 transverse common tangent. 3 tangents. Right? How many tangents are exist? Means 3, because they are going to touch externally. We got it. Now you see here C1 is equal to 2 minus 2 comma 3. R1 is equal to 4 plus 9 plus 3. Right? 4 plus 9 plus 3. So R1 is equal to, you are getting here 16 means 4. C2 is equal to minus 2 comma 1. And R2 is equal to some 4 plus 1 minus 4. You have got it here 1. Now what happened here? You see that C1, C2 becomes under root of this 2 gone. So 3 minus 1 whole square is there means 2. C1, C2 is definitely less than mod R1 minus R2. Mod R1 minus R2 means what? Completely one circle is lies completely other. So number of tangents are what? 0. Like this. Like this we can say position of the circles as well as number of common tangent we can discuss in the same way. Right. The next one is internal external center of similitude. Here center of similitude. Center of similitudes are actually 2 types. Right. Center of similitudes are what? 2 types. One is external center of similitude. Another one is internal center of similitude. 2 are there. What is mean by external center of similitude? What is mean by internal center of similitude? Very simple. See here, external center of similitude, suppose let us say for better understanding I am taking here this example. Not compulsory, this example. This point I would like to indicate with P. That means the definition is very clear. The point of external center of similitude means the point, see here, the point of intersection of DCTs is called external center of similitude, ECS. Right? The point of intersection of direct common tangents is called what? External center of similitude. I want to indicate always with P, Nana. Right? Now how to find this P? Remember, this is C2, this is what? C1, this is R1, this is R2. P divides C. P divides C1, C2, line joining C1, C2. Line joining C1, C2, That means it is very clear. They are collinear. C1, C2 and P are what? Collinear. That's why we are writing here. Divide. P divides line joining C1, C2 externally in the ratio R1 is to R2. Suppose you see that R1 is to R2 ratio is there. C1 is x1, y1 and C2 is x2, y2. So P coordinates are R1 x2 minus R2 x1 divided by R1 minus R2. So R1 y2 minus R2 y1. So in the same way, the other one we are writing here, R2 y1 divided by R1 minus R2. Like this we are going to find external center of similitude. And also one more point you remember, from P how many tangents can be drawn? 2 tangents. Right? Okay, from P you remember here, from P we can draw 2 direct common tangents. We observe, what we observe here, from P how many tangents? 2 direct common tangents we can draw to the given 2 circles. Now in the same way, here what is the definition of this one means? Same thing. The point of intersection of, right, TCTs is called, right, internal center of similitude. ICS, I would like to indicate with Q. Is called what? ICS, internal center of similitude. See here, internal center of similitude, it is going to be exist if the circles are, both the circles are what? Away from each other. Whereas here it is not. It may be away from each other, they may be cut each other, right? They may be cut each other, right? We are getting here in these 2 cases, right? They may be cut each other, they may be what? Away from each other, but direct common tangents are going to be exist in this case. But whereas transverse definitely exists only in this case. These are also what? Q I am saying, here C1, it is C2. Now it is very clear that Q divides line joining. Okay, line joining, you can say like this. Line joining C1, C2 in the ratio, internally in the ratio R1 is to R2. How to find Q? Very simple, same as it is. R1 x2 plus R2 x1 divided by R1 plus R2. R1 y2 plus R2 y1 divided by R1 plus R2, sir. By using this formula, we can find external as well as, this is what? Internal, and this one is external center of similitude. Now, you can say that how many tangents? From Q, we can draw 2 transverse common tangents. 2 transverse common tangents. Now you see here how we are going to find external center of similitude, how we are going to find internal center of similitude. Okay, how many tangents can be drawn from external and internal center of similitude. These all things we discuss here. How many means 2 tangents. These are what? Direct, these are what? Transverse. This is externally divides C1, C2. This one is internally divides C1, C2. But overall I can say that internal, external center of similitudes are collinear with the line of centers. You see that this example only I would like to take here. Definitely these are what? Line of center. Lies on the line of center. This is P, this is Q. You know very well that there lies on the line of center. It is very clear. Okay. Now you see here I have taken one question. It's a little bit big. That's why I did it here like this. The internal, external center of similitude, and also what? Equation of common tangent. Here I have 2 circles are given. What I did initially, here I find the centers. Center of this one is minus C1, minus 2 comma minus 1. Radius, you see here R1 we got it as 3, and center of this one is 2 comma 1. The radius is here 1, we got it. Now I tried to find first external center of similitude. What is that external center of similitude? Here P divides externally, okay, C1 C2 in the ratio R1 is to R1 is to R2. That is 3 2s are 6. 6 and here 1 2s are 2. Minus is there na? Plus 8. 8 by 2, 4. Here 3. And here it is plus 1, 4. 4 by 2, 2 we have got it. Now this is what external center of similitude. That means we have like this. We got it this as what P. Say like this, nothing will happen. This is C2, this is C1. Right, we got it. Now, after getting this P, what I did here, direct common tangent. I want to find direct common tangent. So, line passing through P is what like this. If this is a direct common tangent, it has to touch the circle. That's the reason I said that the line which passes through this is a direct common tangent of the two circles. That means, if it is a tangent, it has to satisfy the rule. What is the rule? P is equal to R. See here, P is equal to R, perpendicular distance. P means what? Perpendicular distance from center. Center is minus 2 comma minus 1. Center is, I have taken this circle. 2 comma 1 I have taken. I substituted 2 and 1 and here plus minus 2. Here plus 2 and minus 4m is there. So we got it here minus 2m. Minus 2m plus 1. You see this. And under root of m square plus 1. After solving, I got it two equations. After solving quadratic equation, but it is easy. M is equal to 0, M is equal to 4 by 3 directly we are getting. After, see these values if I substitute here, M is equal to 0, Y is equal to 2, we got it 1. Direct common tangent. Now the other one, if I substitute M is equal to 4 by 3, I got it another one. After simplifying, see here 3y, 6, 4x, 16. Taking that side, very simple, we got it what like this. Now, what I did here, after this one, I tried to find transverse common tangent. Right, to find transverse, it is very clearly that first of all we have to find internal center of similitude. Internal center of similitude is also same formula I have taken 3:1, but it is divide internally. It is when it is divide internally means you see the same rule, right? Same rule here 3 2s are 3. Here 3 is there, 3 into minus 2. 3 into 2, yeah, like this, 3 into 2, yes, 1 into minus 2, yes sir, 6 minus 2 is nothing but 4, 4 by 4 is nothing but 1. Whereas in this case, 3 into 1, yes, 1 into minus 1, yes, we got it what 4, 3 and here it is what plus is there now, 2, 2 by 4, 2 by 4 means 1 by 2. 1 by 2 means here once again same, the equation of the line through Q, we got it. This is what internal center of similitude. But the line through this one is like this. If it is a tangent, then it could be, if it is a tangent means it's a transverse common tangent. Whatever it may be, P is equal to R condition. Perpendicular distance from where? Same point I have taken. 2 comma 1 only I have taken center. I substituted center here. So that's the reason 4 minus 1 and minus m plus 1 we got it. Divided by under root of m square plus 1 is equal to 1 is there. So that is nothing but after simplifying we got it in this way. M is 0 and M is equal to what? 3 by 4. I substituted here. Right. I substituted and I got the two equations. One equation is this. The another equation is this one. These two are transverse common tangent and these two are direct common tangent. And this one is, right, P is external center of similitude and Q is internal center of similitude. By taking one example, I discuss everything related to internal, external center of similitude and direct common tangents. Yeah, now after this, we are going to discuss some miscellaneous problems in this topic. What are the miscellaneous here? Some example, different types of problem you see here. The number of integral points that are interior to the circle. Okay sir, no problem. Here circle is there. This is center 0 0. Origin it is x-axis and y-axis. The radius is what? 4 comma 0. You see here 1 2 3 1 2 3. Here also what? Minus 1, minus 2, minus 3 and last one is minus 4. How I am going to do? You see this one. Very simple. You can take here x may lies between 0 and 3 etc. you can say, but I don't want to do like that. How I am doing here, you see this. Right, I want to take 0, right, plus or minus 1, plus or minus 2, plus or minus 3. 4 I cannot take. Why? 4 is on. So I don't want to take that 4. Here also 0, plus or minus 1, plus or minus 2, plus or minus 3. I am not taking 4. Here also I have a doubt. So these are what the points I would like to take, x comma y. So x I would like to take horizontal, vertically, the downwards, and y I am taking here horizontal, right, horizontal distance. Now here 0 comma 0, yes, definitely. And next plus or minus 1 exists, plus or minus 2 exists, plus or minus 3 is also what exists. How many number of points are there means? See here 0, 1 point, and these are 2 plus 2 plus 4, 4 plus 2, 6, 6 and 1, 7. You got it here, 7 number. 7 points are there. 7 points. How this point 7 points are there means, don't worry, you can write like this: 0 1 0, see 0 0 0 1 0 minus 1, like this. I want to show you this: 0 minus 1, 0 I am writing, 0 2 0 minus 2 0 3 and 0 minus 3 you are going to write here like this. See, these are the 7 points, like this. So in the same way you take this one, what happened here? 0, absolutely. And whereas in this case plus or minus also it is exists, plus or minus 2 also, plus or minus 3 also. Why? Because if you take 1 3, under root of 1 plus 3 means 9 inside only. So how many points are there? These are 7, and but this is 2. How many? 14 points we have. In the same way you can write 1 3, 1 minus 3, minus 1, minus 3. You can write all those things, right? Now 2 you take down. Yeah, it is correct. And 1 also exists. 2 also, 2 square, 4. Yeah, it is also exists. 2 and 3 you take down. Yes sir, 2 and 3 also if you take here, nothing will happen. Under root of 4 plus 9 less than 16. Therefore it is also exists. How many are there means 14. Now whereas in this case, be careful. 1. Yeah, we did it till 3, this one. But 3 comma 3, you see here 3 comma 3, what is going to happen? Suppose if I take here 3 comma 3 or 3 comma minus 3 or minus 3 comma 3 or minus 3 minus 3. These are 4 points if I take. From origin, the distance from origin to 3 comma 3 you take down. What happened here? 9 plus 9, root 18. Root 18 is greater than root 16, sir. So that means what? It is outside. It is outside the triangle. That's the reason I don't want to take this. Right? This is the reason I don't want to take that one. 3 comma 2 exists, but not this one. That's the reason. Here 2 plus 2, 4, 4 plus 1, 5, 5 into 2, 10. How many? 10 points. Total number of points are what? Just you add it here. 8 plus this 15, 1, 45 points are there. How many points are there? How many integral points? Not points here. How many points means there's a different story. How many integral points are there means these are the integral points. Yeah, for you, I want to write this one. You see, 3 0, 3 1, 3 minus 1, 3 2. 10 points I am writing. 3 minus 2. Yeah, next one is minus 3 0, minus 3 1, and minus 3 minus 1, minus 3 2, and minus 3 minus 2. You see this? 1 2 3 4 5, and these are 5. Overall what? 10 points are there or not? Yeah, that's why I wrote 10. In the same way 14 14 7. So total what? 45. Like this we are going to find the number of points. One more question I have taken here. You see this second one. In miscellaneous I have taken second one. In a triangle ABC, the equation of the side BC is what? 2x minus y minus 3, and its circumcenter and orthocenter are at this respectively. Then the circumcircle of the triangle ABC is dash, he said. So need not worry. You see here there is a triangle we are going to find, right? The circumcircle, he said. Yes sir, circumcircle is this. But the interesting point what he has given here, he has given 2 points. One is orthocenter. You see this? If it is perpendicular, this is a foot of perpendicular. This here he has given orthocenter. That orthocenter is here. Let us say that 2 comma 4 I am indicating here, orthocenter. And the circumcenter somewhere here I want to write, because it's the center of the circle. Need not worry, 1 comma 2. When we know the center of the circle, the only thing is we have to know is radius. If you know the radius and circle center is there, means directly we can write the equation. To get the center we have to use the logic. What is that? You see here now. This equation is also he has given. What is that equation here? Yes, 2x minus y, right, minus 3 equal to 0 he has given. one beautiful point, please remember, orthocenter. The image you see here, image, this is the point if you are supposed to know that. Image of orthocenter of the triangle, ABC. Okay, image of orthocenter of the triangle ABC. Okay, with respect to, you know very well, I would like to indicate 1. With respect to 1 is always lies on the circle. Lies on the circle. This is the beautiful point. If you know this, then only you will get it. How to find image? You see here, h minus 2 by 2, k minus 4 by minus 1, minus 2 into, just I want to substitute here, 2 into 2 minus 4 minus 3 divided by 4 plus 1. Here you see h minus 2 by 2, k minus 4 by minus 1, and after simplifying, this 4 gone, 6. This is what 6 by 5 we are getting. 6 by 5 we are getting here. Now image is, in this one you see h means here, how much you are taking here now? 12 plus this. See Nana, h means here, this and this I am taking, right? This and this if I take here, 2 6 12 by 5 plus 2 you are getting, right? Another one is k minus 4 by minus 1 is equal to 6 by 5. Suppose if I said here 6 by 5, then first h comma k I may get here. In the case of h comma k, that is what, something here, 10 minus 3 we are getting here now. Okay, you see here, simple calculation, image we got it. See how these two if you equate, 12 by 5 2, that is nothing but what, 22 by 5 you got it. These two equate here, minus 6 and 4 if you take that side here, it will be like this, minus 6 by 5 plus 4, that is what, 20 minus 6, 14 by 5. We got the point. That point is here. This become what, radius. So this point is here, 22 by 5 and 14 by 5 we have. So now to get r, distance between center to this point, I got it here. After simplifying, you see this one, 17 you are getting here. Here we are getting what, 4. So right, whole square 289, and this is 1675 under root of 61 by 5 we got it. Now the equation of the circle is x minus 1 whole square plus y minus 2 whole square, because center is 1 comma 2. Circumcenter is the center and the radius is 61 by 5, because under root of 61 by 5 whole square we have to write, and this is the way we are going to solve the problem. One more good problems I have selected here. You see this, what he said here, the range values of r, which for which the point this is an interior of the major segment of the circle, he said. Yes sir, this is the line. Okay, x minus y, see here, x minus y is equal to 2. This hand, okay, this is 4, somewhere here 2. It will be like this. If you say that 2, this is also 0 comma 2 and this is 2 comma 0 origin. Right, major segment means this is in this area. In this area, that point, the given point, say P, lies in this, means first of all it lies in the circle. First of all, this one is lies in the circle. What is that? S11 should be less than 0. So just I would like to substitute the point in the circle equation. What I'll get here? Minus 5 plus r by root 2 whole square plus minus 3 plus r by root 2 whole square minus 16 is less than 0. Right. Here after simplifying r square minus 8 root 2 r plus 18 less than 0 you are getting. Or simply you do one thing, r is equal to, you can write r plus or minus under root of 8 root 2 whole square like this. 4a c is what, 18 divided by 2a 8 root 2. You write like this and simplify. So after simplifying this, you got it here, we'll get 4 root 2 minus root 14 is less than r less than 4 root 2 plus root 14 you will get. This is equation 1 we are getting. Right, two roots are there, lies between. So you see here x minus a, x minus b less than 0 means, sir, you can know very well, no? This no, yes, no. That means x belongs to a comma b. By using that concept, I did it here. right? And the other one is, see this point and origin lie same side of the line. Okay, what is that? P and O, origin lies, okay, lies on same side of the line. Same side of the line concept we are supposed to use. That means what? Origin, if you substitute in the line, definitely negative you are getting. So when you substitute the point, it should be you should get the same one. So now, while substituting origin, what do you got here in the line? See, 0, 0, minus 2 less than 0. It's the same story, sir. LP should be what? Less than 0. That means here minus 5 plus r by root 2. And here minus 3 plus r by root 2. Minus 2 less than 0 we are getting here. Now, after simplifying, you see this one? 2r by root 2. And this is how much here? 10. Minus 10 less than 0. So r is less than 5 root 2, you can say that. R is less than 5 root 2, you can say. This is 2. From 1 and 2, 1 intersection 2 you have to do. 1 intersection 2 you have to do. 1 intersection 2 means this is 4 root 2, root 15 is much bigger than this one. So you can say that answer is 4 root 2 minus root 14 less than r less than 5 root 2, you can say. Sir, I shown to you that how to solve this all. Right, I don't have that much more space here, that's the reason I did it. Right, like this we can do the problem, sir. Okay, this type of problems we are having in miscellaneous. Right, I tried here to explain few problems here. In the next class, we'll continue this. Okay, thank you.